4, 5, 6 seconds. Okay, Cameron. So, Cameron's working on his. What is? Oh, he's taking a picture of the water fuel cell down there.
Oh, it's just so exciting. This water fuel cell is so exciting, and I know the viewers at home are excited about it too.
I'm excited about it too. And you were
We've
just.
got to do something in the near future with that.
Yeah, we're gonna go back and work on water fuel technology again with these. I think we could integrate these circuits into the water fuel technology. That would be fun too. Oh, that was a good picture. Can I see your picture? Can you do that again? Take a new one. Do the same framing.
All right, I'm framing
is-
about like
that's Cameron's
here.
picture. Very nice picture.
But I try to get no glare on the meters, so I'd have to be.
Very good.
I think if I'm more on this side, that's a less meter glare. But
Well, I'm glad you think of that, Cameron. I think of that too.
I want the viewers at home to see the data that they need.
Yeah.
So what you got going on here?
Well, what I want to ask you, Cameron, I would like to ask you what you see.
Well, okay, I walked in here, and I saw these two copper plates separated by like an insulator,
Mhm.
plastic.
Yeah.
And so I knew it's like when Joseph and I talked about there was a mat in my house, an exercise mat, and I pulled the mat up, and then the hair on my arm shot up, and I touched something metal, and I got a shock that almost knocked me on the ground. And so this is like some sort of, it's a thing that allows energy or electrons to transfer from one side to the other, and
Yeah.
it seems like it could be sort of a basic capacitor similar to it.
And that's our human thoughts based on what we've been taught and what we've learned on our own. We don't actually know, like you were saying, we've never seen an electron, right?
I've never seen one, and I'm not an expert. I'm just a dabbler in electronics, but
Yeah.
I do like to research it more than your average bear.
And I dabble in beginnerism, if that's a word. Is there
It is now.
beginnerism?
Mm-hmm.
Okay. So, Cameron, what do you see here? Can we follow the path of electricity just for fun? Or what do you think? Should we follow the river?
Why not? Well,
Let's start at the battery. Let's start at the big battery in the back.
Okay, so this
That's
is,
like an 84-volt battery or so, right?
yeah.
when it's full.
This is an Onyx motorcycle battery that is not a stock one, and so you've got.
It's a big one,
I
huh?
got to be careful with my fingers because it is between, it could be as low as 58 volts and as high as 84 volts. So if I
Yeah.
touch those, I could blow myself up. So I'm gonna not touch. But
Well, it's DC, but it is high voltage, so I guess it could hurt you, couldn't it?
I don't know. Can you stick your two fingers on 72 volts? And I'm not trying it.
I don't know when DC becomes dangerous, so that could be looked up on Google probably.
I know when you touch it with metal.
Yeah,
it
absolutely,
explodes,
yeah.
And we've got, we
Yeah.
both have had things happen.
Yes, we have.
So I'm following anywhere between, 60, 70 volts
Yeah.
through.
It's
this
around
the
80.
Anderson connection through the wire.
Yeah, okay, let's go
and the
slow.
wires.
Hang on,
Okay.
go slow.
So Anderson
Let's follow the
connection.
positive, because this circuit, we call it, Rick Friedrich, I think, refers to this as splitting the positive.
Okay.
I think John Bonini talked about I don't know if he called it splitting the negative, but I think he was using the negative. I don't know what the difference is between splitting the positive and splitting the negative, but right now we're running everything through the positive. So what that means is, well, actually, I don't know what we're doing here because this project actually evolved and evolved and evolved, and it just kept becoming. I don't know where this is going. Actually, I want to connect this circuit to my battery on my car, on my I have a hybrid, so it has a small battery in the back, but the more I can keep that battery charged is the less fuel I can use, like in the city, for example, on that particular car. But anyway, but it also would be interesting to maybe power like a little toy car, electric toy car or something, or an electric, helicopter there. That might be interesting too, just for experimental purposes. We'll see what happens. But Cameron, go ahead and follow that path. So we have the big battery here, and go ahead and follow the positive slowly, very slowly.
Okay, so positive from the battery.
Yeah, where does that go right
The
now?
Anderson connector to the pigtail, which is being supported, insulated, going to a lead of this meter.
Yes, that goes to that meter.
In addition, is this connected there as well? Is that just in proximity or is that connected?
It's connected. This wire here?
Does this connect to this? Oh, that's all. Okay,
No, that's just yeah. This is just the cover that I
Okay,
pulled
they're all
back.
connected. Okay,
Yeah, everything's
yeah.
connected.
All right.
So this is connected to the motor,
Mhm.
and then this is the meter, and then this is connected to the plasma globe, because I just wanted to see what would happen if I connected that. And this plasma globe, by the way, requires the power supply for this particular plasma globe here. Or we can call it a Tesla coil, with gases inside. The Tesla coil would be, I guess that's the circuit. I think of it that way. That is a 240 volt. This requires 240 volts to make this work. Now, when I plug this into 120 volts into the wall, because that was the adapter I had and it was the wrong one, this just had a small little light coming up out of it, which is actually what it does when I connect the circuit, which I'll do right now just to show you. So when I connect this circuit, when it first turns on, it's really active, and then but then what's interesting to me is, even when it's running normal like this, that looks very similar to how it looked when I had it powered by the 120 volt wall outlet plug, which was not the correct voltage for this. Now, what's interesting, if we look over here, Cameron, now that's being powered by. This is being powered by the this just by this each side of this motor here. Okay. Positive and negative going to the power here. Okay, positive and negative. I just matched the colors, red to red, black to black. Interestingly, the same if we read the voltage here, it's at 6 volts. So how interesting that this is even turning on. That looks smaller than yesterday. I was doing some experimenting here.
Now, is this right here, this little plug that your black and your red pigtail are connected to? What voltage goes into that? Is that 120, or does that go from a converter thing?
That wants 240. That's what.
That wants 240.
I mean, wait a second. No, I'm saying that wrong. I'm saying it wrong. I can't find the plug at the moment.
Okay.
But the plug was meant to convert 240. So even though it plugs into a regular outlet like our outlets that we have with the two with plugs that look like this, even though it plugged into that, it wants 240, and then it converts that. That's what was happening. It converts it to what this wants. I don't actually at the moment know what this wants. That would be on the original plug.
Okay.
Excuse me. But what's interesting is we're sending into this a very low power. We're sending into the 6 volts, according to what the meter says. 7 volts. This is what's going in there. This is just being powered here. I mean, how interesting also is it that this is the positive wire, Cameron? This is the positive wire, and this side's negative, even though this whole wire is positive. How does that work? It's interesting. Now, maybe people that know a lot about electricity would already know why that is. I don't happen to know why that is. Okay, so, and it's really exciting not knowing, because I have so many questions. And even when I learn different ways of seeing this from people that know more than me, I remain very curious, because there's going to be more to the story than what any one person can share. Because nature has a voice too. It's the voice of experience. I think of it that way, because experience gives us access to all these other questions and all these other possibilities of what's happening. Well, I do hope that you can all hear me talking, because I just realized it's so loud right now. So I'll quiet this down. And by the way, I'm just connecting and disconnecting an alkaline 1.5 volt non-rechargeable battery. Apparently, alkaline batteries love this energy because they charge up. And they haven't been foaming or anything, because I've tried charging alkaline batteries like with regular rechargeable battery chargers and just other ways of charging, and they'll make they'll start leaking something out. These are not doing anything, even though they're being charged in this circuit. So, and also we'll follow that path right now. So just to show you how this was being connected, I was just completing the circuit here, and that was getting that going. Okay, so Cameron, go ahead and continue, and if I'm interrupting you too much, please just let me know. But go ahead and follow. Let's continue our path. So we're following the positive wire coming from this big 84 volt, approximate 84 volt battery, Go ahead and continue, please.
Well, we ended up here, so it was going into the motor, which did you call it a generator?
I would just call it it's a motor. That's what it
Okay,
is.
a motor.
I don't know
All right.
what it's doing.
Um,
and this can be any. This is a an aeronautics. It's a General Atomics aeronautical servo motor. I think it's a 25 volt is what I was originally told when I purchased it. I purchased several of them. Like they're basically like a surplus place that recycles aerospace technology to the public. In the public hands. So, but this can be any DC brushed motor, and it might be able to be other things too. But I'm just putting a DC brushed motor in there. That's what I had, and I thought, why not use it? So, I don't know how different it would be if I used a different DC motor, brushed motor. But go ahead, Cameron. So it's just going through there. Yes, it's going through there.
going in this side seems to be coming out
Yes.
this side.
Yes.
And so then you are sending it to this clip, which
Goes to the other meter. Yeah, it's just sitting
to
on there.
which meter?
It goes back to the same meter.
To this meter?
Yeah.
Okay. All right. Because that's underneath something, so I can't
Yeah.
tell that one.
Here, let me pull it out.
Um,
Go ahead and pull it out there. Yeah, it's out.
So all right. So it's black, so I'm just gonna pretend it's negative. Going to this meter,
It's negative.
and
And it's showing a negative polarity too.
and then this positive from the meter is going to. I can't necessarily tell with stuff.
We can move it, go
Just
ahead.
Tell me.
Yeah.
It's
go-
this thing.
Yeah, follow
and
it.
it's this guy.
Yeah.
Okay, so it is back to where we had our positive coming from the Anderson connector. So
wait a second. What? Say that again.
Um,
The meter's going. Yeah. So you're saying
the
the
meter's going back. Okay.
the positive goes here, which is
Mhm.
also going to the connector, right? Is that what you just said?
Yeah.
Yeah,
it's-
that makes
where we
sense.
were
Yeah,
earlier.
that's right. It's all
Yeah.
connected together.
Yeah.
And then the
So-
negative is going to the other side of this motor, right?
Mm-hmm.
And the negative for this circuit here is going to there too. Okay, so that's the power.
So it goes to, what is the thing called that powers a Tesla coil? What is that?
I'm just gonna call it a circuit
Okay.
because I don't know what else to
So it
call
goes
it.
to the Tesla coil circuit.
Yeah.
And out of the Tesla coil circuit.
And this is the one that came with it. It's just pulled out of that.
Okay.
Yeah.
You've got.
I ordered it on Amazon. It's called like Plasma Tower or something. Go ahead, Cameron.
It's going through this. What is this meter called? Clamp meter.
It's a clamp meter.
Which does what?
Reads, well, it's supposed to read amps, but
Mhm.
leave it clamped. Yeah, it's because I put it on there just right.
Okay. Okay. It's
Sorry,
still
you,
got the
if
same
you want to,
number.
you can take it off. But I'm just saying, like, you can take it off. Go ahead, because you want to. Go ahead. I'm
out
putting it
here-
there. I'm putting it there because I'm getting more of a reading there. See, one of the things that Tom
Why
Bearden
am I
talked.
getting a reading out here?
Well, you have to zero it out.
Oh.
Well, there is energy everywhere, by the way. So let's zero it out. Yeah, and then you can just put it back on there at zero.
Okay. So out here, there's no energy, but
Well, there's a lot of energy. There's hundreds of thousands of volts, actually, of potential
so
everywhere.
here we're getting.
We're in a sea of energy. That's the whole idea. We're swimming in a sea of energy. We're breathing it. We're walking through it.
Huh.
Well, there won't be anything now because it's not on.
Oh, it's not on. Okay. All right. All right.
Yeah, let me put it on. Let
Yeah,
me
go
turn it
ahead.
on. Okay, so because you want to look at power, so
Sure.
let's do that. Hang on. Let's go connect the circuit again, and we're gonna keep following the path, everyone.
Oh, look, just with it out in space. This is really fun. Why don't let me video this and you go do that again. I'm gonna here and you go turn it on again. The
Okay.
viewers at home have got to see this.
All right. Ready?
Yeah. Yeah, it jumps all over the place. So that's pretty exciting.
And the reason I'm reading it the way that I am is because Tom Bearden talks about how well, not just Tom Bearden, but just the people I'm researching, which is many people. And it's the accumulation of all that information that leads me to say what I'm going to say. So it's not any one person, I think, but maybe any one person also has said this as well. But if the meters are reading dissipation, right? Dissipation, which is coming off of the wires, right? This kind of circuit, does it still have dissipation, or is the energy flowing into the circuit instead of leaving it? I don't know. But I'm looking for the energy. I'm looking for how to read the energy. So whatever reading gives me the highest number is what I'm looking for. That's just my own thoughts. Oh yeah, I see what you're saying. That's very interesting, Cameron.
So there's
I'm really
energies of
glad.
sense all
Yeah.
over.
Okay, you're hired. You got the job. It pays pizza, right?
Yeah, exactly.
Pays in pizza. So I really like. I think that your approach to measuring things and your process of seeing definitely influenced in a positive way my experiments, because I'm always looking for the anomalies. What's happening over here? What's happening over here? What if we do this? What if we do that? What if we change this? What if we change that? I want to try everything. And I am, by the way, because I had a ball of light that was blinding. I couldn't see for a little while. When that's happened many times in my life. I'm surprised that my eyes still work well. I'm really grateful they are. But I'm going to get a welding mask, because guess what a welding mask has? They have auto-dimming welding masks.
Sure.
I'm going to start wearing one of those. So when I'm doing new experiments, in case it flashes real big ball of light, and I'll tell you how that happened earlier in a bit, how I think it happened, because I have to try to remember. I've made so many videos recently that it's hard to keep track of everything I've done. But I know it's all documented there. Excuse me. So there was a ball of light, a big one, and it was super bright. And I think what I was thinking of is doing electrolysis, right? I'm calling it that, but maybe we don't call it that, but I'll just call it electrolysis. It's just putting two plates in the water and releasing the gases, right, from the molecule. And at least that's how I'm thinking of it right now. So I think what I did with the circuit, if I recall correctly, and I could be wrong in the way I'm saying this, is I used, because let me see how we're doing this right now. I don't know if I can remember. I think this, instead of charging the battery, because right now you're going to see how this is wired into the battery. I guess we would call it, in a way, series, even though it's splitting the positive. Everything seems to be in series. Let me stop this. Even though it's splitting the positive, I think of it as being in series. Just observing it, right? Because look, right? Series, if we go around and follow this, where does it go? And I know we're going to do that again, but so this goes here. So right now I don't think we're using the plate across, but there could be something happening there. I'll look at that. But really, we're just coming into here and then going to this battery. I wanted to use this battery and see what would happen if I have this battery in series. I'm calling it in series. This is still the positive, which goes positive, negative by itself by connecting these to everything, right? It's positive in here, then negative out, and then positive in, and then negative out, and then positive in, and then negative out, right? And then, so this side, where does this side go? It goes back to the battery. So that kind of seems like series to me in my beginner thoughts. So, but is it splitting the positive? Is it series? I don't know. It's both. Maybe it's both. So, but go ahead. How did I make that ball of light? I think I was trying to charge this when the plates were really close together. I was trying to charge this so that I could put it in the water and release the gases, and I think that's how I did it.
Was it an instant and temporary ball of light, or
when I touched this here,
yeah,
there was a ball of light, maybe that side. It was really pretty big, and it was so bright. And when I say that, how long did it last? I don't know how long it lasted. I'm sure it was a fraction of a second, but it was really, really bright and big. And I don't know why it did that. I don't know why it did that. It seemed different than when I just touched.
Call it a plasma?
Yeah, it might call it a plasma. I don't know. And this wasn't in the water at the time. It was just sitting here in the air, being suspended by zip ties. And the gap was smaller. But usually when I touch this and it sparks, it'll spark, right? But that's not what it was. It was like an explosion almost, like a small one. I mean, I'm using that word because Robert calls it that. At Robert's Computer Hospital, he's like, yeah, that's an electrical explosion when something sparks. It's like a little itty-bitty explosion when something sparks. So I'm like, okay, that's an explosion? Okay. So it was a micro explosion. But it was a super bright light. And if I wear an auto-dimming welder's mask, that should darken the flash before my eyes can even see it. That way, if I have that kind of accident in the future, and I do wear gloves when I'm doing something new like that for the first time, that it won't affect my eyes at all, which is important. So Okay, Cameron. So go ahead and let's follow the path, Cameron. I'm sorry I keep interrupting you.
Where were we? What was the
I
last
think so.
thing?
We left. So we left the motor. We're leaving the motor now. So we got a positive coming in.
We were in this guy. We were in your
Oh, yeah.
clamp meter.
That's right.
So it was coming off through the clamp meter, and then that's attached also to this Tesla coil. So
Yeah, it's a plasma globe. We call it
Uh,
Tesla coil though.
plasma globe. Yeah.
Yeah, it's a plasma globe. Plasma tower.
So this has one wire coming out of it here. Is there another wire coming out of it
No,
somewhere?
that's just the one wire that the circuit usually connects to. So that wire usually connects to this wire, which I've just used. That usually goes to this. That's all, and it was just cut.
Okay.
That's all. I just cut it to pull that out, and I burned this up, and Robert's Computer Hospital fixed it for me. I think he said I burned these out from doing experiments, different experiments, not this kind of experiment, something else. It was a different one.
Mm-hmm.
This experiment hasn't harmed that. It's been working fine. Yes,
So
Cameron.
we can go to the negative of this here battery.
Or let's follow the positive still. You
Well,
want
I
to?
got to here. Where's it from there?
Oh, to here. So here it just goes to the plug. See? Do you see
Yeah.
the plug? This is
Yeah.
usually where the power comes in from the wall, right?
Mm-hmm.
And that's just going to the positive, which goes to the positive battery. But then the negative just goes to the other side of this motor. How interesting is that? I mean, to me, that's very interesting. But the negative just goes to the other side of the motor. And we're going to follow that path right now. We're going to follow that. But, so that's the positive and negative. What are your thoughts, Cameron?
I don't entirely. Even if you showed it to me in a diagram, I wouldn't necessarily know
Yeah, me too.
what's going on. So
That's how I feel.
honestly, I do not know.
I don't know
wish I
either.
knew,
But I just want to
I'm
know
not
what your
sure.
thoughts were. So your thoughts are that you don't know.
My thoughts are I don't know what's going on. I mean, it sounds dangerous that you had the explosion and that was potentiated by this giant 84-volt battery, I guess.
I don't know what happened. Yeah, we can guess that. Because I don't think, well, I guess a AA could do that too.
You were telling me that you thought you had quote unquote like manufactured dirt. What's that?
Oh.
Tell me about that.
Oh, transmutation. I don't know if if we call this transmutation or if we call this making dirt. But when the capacitor, well, is this a capacitor? When this was close together, but they weren't touching because I had double-sided sticky tape in there. You can see that little. Let's see if I can zoom in. Those little pieces there are double-sided sticky tape, and those are keeping the two plates separated when I had them close together to prevent them from touching one another. Right now, there's that spacer in there. I put that in there now, but when I was doing these experiments, that was not there. That was on this side. I had that over here on this side, and these plates were real close together, and I was spraying water in here, which was allowing the circuit to start working when I would spray water in here. But when I read on the meter,
Was that distilled water?
yeah, it's distilled water with Epsom salt in it. And I learned about that from Aquatune, because Aquatune at the time was using a pinch of Epsom salt. So I thought, I'll use Epsom salt. If Aquatune can use it, which is a water fuel technology, I can use it in my experiments too. That's what my thoughts were. So when I would connect it to here, it was showing open line. So it's showing open line with the water in there, but yet it was completing the circuit, right? Because these have to touch. These two wires have to connect for the circuit to work. And if I take this wire right now, that's coming from that motor, and I go past the battery, and I just go right over to this negative, it'll work. It'll spark a little, see? But it works. So my question to myself was, how come it's working when these plates are close together? The plates were also holding a charge, even with no water on them. They had like 1 volt or 1.5 volts approximately, which was interesting after I did these experiments with it, and the charge remained there. Could I use the charge? I didn't find a way to use it yet, but I didn't spend a lot of time on that either. But it was interesting just to see a reading there. So what I noticed was I was spraying water and I was doing these tests, which you've seen if you've watched any of the short videos, the early ones. When I say early, it's a few days ago. But when I separated these plates, and these plates were perfectly clean, and this is what I was telling you before we started rolling, Cameron, is that these plates were perfectly clean, and when I separated them, there was a lot of, well, I'm saying a lot, but there was to me, it was a noticeable amount of what appeared to be dirt. Now, where does the dirt come from? Where did it come from? Look, and it's down there. A lot of it is. You can see it down there. I made videos of that too. But
well, I mean, I'm guessing that salt, which is like NaCl, sodium chloride. So you've got sodium and you've got chlorine, you know, bonded chemically or something.
mm-hmm.
Maybe you broke that. Maybe you've got, you know, I see green and I see black in there. One of them might be sodium and one of them might be chloride. I wonder if you were to dry that stuff, if you dried all of it, I'm not saying do this, but if you took, I got this idea because yesterday I was filling somebody's fountain, okay, and a pool man had come and put chemicals in their fountain to make the water not green, okay, but it was, part of the fountain was empty, and I got to see these white, sort of, I don't know, white powder in the bottom. And when I started spraying the hose in there, some of the white powder got on my skin, and my skin felt like it was burning, okay? So white powdered bleach can make your skin feel like it's burning. If you let this dry, and then you gather whatever the material is there, you know, is the sodium the type of sodium that like strips electrons from biotic materials? You know, you could actually touch that stuff, or the worst thing would be to touch it to your tongue and see what it tastes like.
And to clarify, because I may not have said this in a clear way, at the bottom of these two plates was a lot of dirt. There was nothing white there. It was just dirt, like you would get from the ground. It was just dirt in the bottom, not that what looks like in there, all those colors. There wasn't all that. It was just dirt. And when it dried, it was dirt. It didn't look like anything. It didn't burn my fingers.
Mm-hmm.
So I don't know if that's being pulled from the air. I don't know if it's something to do with this energy. If this is negative energy, which this is supposed to be a negative energy circuit, if I'm doing it correctly, if I understand correctly what is negative energy, what's positive energy, I don't totally understand that. But if the energy, because it's different, by using a circuit such as the one we're using, we'll just call it splitting the positive for the moment, if that energy flowing between these two plates, with the salt, with the air, with the moisture in the air, and with the water, somehow allow actual dirt to be made. I mean, where's the dirt coming from? Where did the dirt come from? That's my question. So what makes dirt? You know, we have a whole planet full of dirt.
I'm looking that up because I've had a lesson before. Dirt is made out of 3 different things, and I'm going to try to find what.
Oh, that's awesome.
It's either dirt or soil. Maybe I'm wrong.
Okay.
Soil.
And we could also clarify the difference between the two.
It's like rock.
That's the voltage of these batteries right here.
Material. Minerals, water, organic matter, gases, I didn't realize that, microorganisms. So, you know, I guess it depends on who you search and for what age the material is for, but
yeah.
I remember having an elementary school lesson that it was either talking about dirt or soil is made out of like rocks and decaying plant and like animal matter and, you know, minerals or something. I don't know. I think rocks and minerals are interchangeable. But in the Epsom salts, I think there's got to be minerals in there, and maybe you strip the minerals and sort of fried them and burned them in some sort of way through, you know, the electrical energy going in there. Could have discolored them. I see the water is kind of discolored.
Yeah, and it just looked like dirt. Like when I rubbed it in my hand, it looked like little pebbles of dirt. We'll have to make some dirt sometime, Cameron.
I know that copper is something that wants to erode, and now that I'm looking in there, the green, okay, you've got bits of green which are gonna, some viewer at home probably knows, that's gonna be copper corrosion, the green, because you look at the Statue of Liberty, and doesn't that turn green over time? They've got to kind of I don't know. I thought green was the color of copper tarnish. So maybe what you were doing increased the corrosion of the copper, and copper itself could be pure or not. And a guy who works on plumbing and stuff told me recently, as I was showing him a leak on plumbing, he said, "Oh yeah, that shouldn't be leaking now because that's not quality copper. It's got contaminants in it. That stuff should last 40 years or something, and it was leaking after like 10, 15 years. So I wonder if your copper has imperfections in it, just due to whatever grade copper that was, wherever you got it from. Maybe it doesn't need to be that pure. So maybe the corrosion happens more readily based on the quality of copper."
Yeah, so anyone that wants to test this could get many different grades of copper, many different grades of aluminum. This is regular aluminum. And then get the plates, really close together, maybe a couple millimeters within one another. And you can vary the distances. And it could be more precise than this that I have here. And I just sprayed distilled water, which has Epsom salt in it, and you can vary the amounts of Epsom salt that you use. And I use the spray bottle here. And we're just turning the fan on. Okay. That's the fan. Hi, fan. And then see if you can make some dirt by just spraying it in there. And then just having the circuit. So let's finish the circuit, Cameron. Let's finish the circuit. And thank you for sharing your thoughts, Cameron.
So let's see.
So I think we're coming out of the motor. We're coming out of the motor now.
On the black side?
Yeah.
All right.
Because this side reads as negative. Yeah. It's reading as negative.
We had coming to your
back to the plasma globe circuit. Yeah, right here.
You tell me, because I feel like we covered the red wire going into it. We covered the black wire going into it.
Yeah, and we got.
Where do we go next?
And then we got the positive. We got the positive and negative going to this meter. And now let's just follow the wire that goes out of here. Let's follow the next wire, which is this one.
All right, so it's a red wire. And
it's a red. Yeah, I kept it red because this is the positive wire, but on this side it reads negative. Okay. So this is still the positive wire that came out of this circuit, though. I'm saying it that way. So go ahead, Cameron. Go ahead and follow it.
So now you are going from. Let me get something good to point with. Can I point? Is the end of that safe to point with?
Yeah.
Okay, so, the white is cruising all the way over to.
That sound might interfere with your voice, though.
Yeah, cruising over to.
Yeah, that's not going to work. Huh? It's a live.
You tell me what's going on here. There's a lot going on. What is it going?
Well, just follow the wires. I want you to follow it. Follow the red. Where's red? Red's here, right? Mm-hmm. So red's here. It goes here, and then it goes to the positive side of these batteries. These are alkaline batteries, alkaline energizer batteries. Non-rechargeables, but they love being recharged by this circuit because it's working. These are 1.5, or I guess, yeah, these are 1.5 volts when they're new. And these were all had been sitting for I don't know how many years, and they were completely drained. And this system brought them back to life, if we say it that way. So if we follow this, it goes to the positive, okay, of these batteries. Do you want me to do it, Cameron? You want me to do it?
You go ahead and do it. I'm not gonna.
Okay.
Be good at explaining it.
The negative side of these batteries then just goes to this negative. This is a meter. This one's a meter. These white ones are meters. So we can follow that too. So this white one is going to go to the negative, or the black of the meter. So we'll follow that. See that? And that's this meter here. So that's giving us the reading on that battery right there. This has been hooked up all night, so it's probably draining it real slowly. I just left everything connected. And then this side this white one is the meter as well, and that's going to be the positive side. So that's the positive right there. And so even though we're in this whole wire coming out of the battery is positive, it's reading it as the correct polarity, because if it was in negative, it would show a minus there if these were backwards. And if I reverse them, they would do that. And I can show that real quick. So if I reverse the polarity on these, it's called reversing the polarity, but it's just changing, you know, the wires around. Now it's going to show a negative, see? So it's reading one side as positive, one side of is negative, which is interesting because both sides, this whole circuit is positive. It's all coming from the positive wire. I'm thinking of it that way. So I'm still learning a lot, but I'm just sharing my thoughts with you. So we have that. So we're back to normal polarity. See, positive is positive, negative is negative on this battery. And let's follow this wire. So it goes around. Oh, going the wrong way. Goes through there, and then the negative. So it goes through here, and then this wire. Where does this wire go? It goes into another motor. So it goes in one side, right? Goes in right there. And it comes out the other side. I don't know if the color is the right color to use, but this just showing you the path. So on this particular test, I was just using, because I opened the space up, so I just wanted to see what happened. I wanted to see how far apart these plates can be and still let the circuit work, but I have to go slowly. I just opened up a lot, and it wasn't doing the same thing. Like when I connected here, it wasn't completing it on this side, but when they were real close together, it was. And especially if I put water in it, it loved that. But and it was making bubbles too, which I wonder if that's Brown's gas. I guess it would be. That's my guess. It's just a guess.
Is Brown's gas hydrogen?
Yeah,
gas,
yeah. People use it to increase their fuel efficiency and stuff like that. Increase combustion efficiency. So in oxidation efficiency and reduced emissions. So let's see. So let's see. So this wire coming from the motor here, that wire goes to this plate, and then on this particular circuit, because I bypassed this system to charge this battery, I wanted to see what would happen if I charged this one alkaline battery right there. So then I have this going over here, and then I just put it here when I'm not using it. But this is the one that when we connect it there, it causes that system to do that. Completes the circuit. So this wire, so basically the wire coming out of the motor is going to this battery. That's basically what's happening, because we're just going there, see? That's the same thing, look, we're going from the motor. This is the motor wire. So we could just skip that plate altogether, see?
Does it operate the same if you connect it directly with no plate? If you bypass the plate, how does your plasma?
I don't know, I haven't tested that yet. That's why there's so many.
So if you literally just connect this one to that one.
Then it won't charge this battery.
Okay. But
I don't know if I had the battery on there and connected. I don't know what it would do. I have to be careful when I do that. I wear this shield when I do things like that with the batteries. When I'm doing something new, I wear this face shield, and I wear gloves, and I'm really careful because when I'm doing something new, I don't know what it can do, but I know the energy. I feel really comfortable with the energy because it's this kind of circuit is, I don't know, it's been going well. Let's just say it that way. It's been going well with the testing. So aside from the bright flash, which was a mistake I made, I should have had my eyes closed. Now when I touch something for the first time, I close my eyes until I get the auto dimming welder's mask, which they have on Amazon for like starting at around $35. They don't have to be the $1,000 ones. It could be a $35 one, I think. And then Harbor Freight has them as well. They have their own version, and there's a coupon for this weekend for 20% off. So for anyone that wants to use that, you can. I like Harbor Freight. Okay, so what else? So right now we're just showing that we're going, so the circuit, so basically this, out of this motor, the positive wire, is basically going to this battery in this configuration, and it's charging this battery the same way that this one charges, the same way that these are charging. And then it comes out, and when it comes out, I have it going to this plate, but at the moment for this particular test, this could just as well be connected directly to this wire, and it basically is, right? Because this is aluminum. and then it goes to the let's see, it goes to the negative of the same battery. So I mean, just looking at it right now as an inexperienced person that is still learning, it almost looks like everything's in series. So does this even qualify as a splitting the positive? I mean, I'm calling it that because it appears to be that to me. I mean, how is it charging? What I want to do is just put all kinds of different batteries in series with this circuit, all kinds of different voltages and lithium, different chemistries, and see what happens. And of course, I will be careful. I probably have 6 fire extinguishers here, and I have my shield, and I have, you know, I'm going to use all the safety I can use, but I'll be very careful when I do this. But I'm curious what happens to the batteries. Are all the batteries going to charge at their own proper voltage? I mean, to me, that's I'm just going to say, I'm just going to call it the intelligence of nature, you know. I'm just going to say that. I mean, nature appears to be intelligent so beyond what I can even see, that I'm gonna call it that. You know, it's like Rick Friedrich recently said when he said, how did he say it? I forgot how he worded it, but he said, I don't know if he used the word supernatural, but there's a word like that, where it's, you know, things are just so incredible and amazing. And that's really how nature is, you know. I mean, people that know, you know, so much because they've been studying their whole life, they say they're still getting started because they see the endless layers to learning about nature, the endless layers. There's just endless. Well, okay, Cameron, so we're supposed to be going to the beach to ride our scooters today, and you got your new scooter. I'm really excited about doing that.
Yes, I'm looking forward.
This couple-minute video turned out to be 41 minutes, or 40. So, Cameron, are you okay?
I'm okay. Let's finish the video and go scooting, and the viewers at home can arrange their own setup like this.
Yeah. Part of the reason, exactly. Everything I've learned from you guys. I just want to thank all of you, your questions, your curiosity, your passion to learn, your enthusiasm for sharing what you've learned, your sharing of your thoughts, your sharing of your imagination, your sharing of your passion for your education. And when I say education, don't forget, teachers love learning. You can teach your teachers; they'll love to learn this. Maybe not all of them, but I've been lucky enough to have great teachers that say, "Please teach me." So the great teachers to me are the ones that say, "I learn from my students."
Mediocre teaching is just knowing it the night before from a book, telling some students some stuff, and just thinking that's all there is. So there is a lot of mediocrity out there in education. So you have to find someone who wants to communicate and actually wants to teach and listen. I guess listening is a good part of teaching.
And you're hearing that from a teacher.
Sort of.
Well, you've taught, right, Cameron?
I've taught.
You've taught. Yeah, you've taught classes.
Yeah.
So, that's like saying I'm sort of a beginner, right?
But like you said earlier, every day is like being a beginner.
Every day is like being a beginner.
The forces of nature can teach you something new every day.
That's right. So what will you do with this circuit? And look, you could look on Rick Friedrich. There's many people that are sharing this kind of experimentation, but one place that you can look is on Rick Friedrich YouTube channel, Rick Friedrich. And he has, I think one of the ways it's described is the loving giving path. So any videos that talk about the loving giving path, which is where you're giving a charge from one battery to another. And when you do that, there's so many possibilities of what can be done, because that's how nature works. It works in an open system. I think Thomas Bearden called it the open super system. And he called it a super system analysis that's how you find more of what's taking place. It's a larger perspective. It's a larger way of looking at something. And don't forget to teach your teachers. They would love to learn everything that you have to share with them. And again, not all teachers, but like I said, I've been lucky enough to have teachers that are eager to learn about the new thoughts that they hadn't maybe considered before.
This brings me to a question I want to ask you. What do you think about dropping a class? Let's say you're in a class, you want to learn chemistry or electronics or some science class. And let's say on the first day you talk to your teacher and they are not communicative. You tell them, hey, I'm interested in this, and they won't entertain your thoughts or talk to you about it. Do you think it's ethical to withdraw from that class or change teachers? Joseph, what do you think?
Okay, so I'll just have to talk about my own experience, and that is, if there's a class I want to take, I would read all the books before the class started. I would ask a lot of people, including faculty and the people that work at the school, about what would be a good fit for me. I tell them what I'm looking for, because I don't want to get to that place where I have to drop that class. I don't want to get there.
Yeah.
I want to know, because good teachers have a reputation for being enthusiastic, great, and you see the class fill up fast. You see that. It's the one that you have to wait maybe a couple semesters to get in, or wait at least one semester. So I would say research first, just like everything. I didn't start experimenting until I read some of these books several hundred times. Sometimes I think something's wrong with my brain because it's so hard to retain information, but I think what's happening is I'm thinking of so many different new questions as I'm reading. Maybe it's hard to focus on what the message of the writer is saying unless they want me to see all those imagery and see all those possibilities. And in which case I would say, thank you so much. Very good writing. Because every time I read any book, I'm seeing new things each time. But Cameron, did I answer your question with the class?
I like how you answered it, because I'm just thinking of, like, there was one, I think I've withdrawn from 2 classes in my whole life, and I remember it as though, like, I did something morally wrong. You've got to, do well in all your stuff. But I met a chemistry teacher once who we butted heads and we didn't get along, and I'm glad I dropped his class. And then another class, I had to drop an anatomy class. It was just I was with people who had a different major, and they already had previous knowledge that they were using to succeed in the class. So, but I really like your method where you don't even enter the negative experience class. You use research to enter the class that you know is going to be good. So
Yes.
I'm glad I asked you. It's good.
And 100% of the time that's resulted well because I asked enough people that, and they got to know me, they listened to me talk about what interests me and what would be a good match, and it's worked well. So it's hard to imagine being in that situation, but I do imagine I would do what you did, which is to get out of the class, even if it meant, having to wait a while to get the class, the better match.
Mm-hmm.
So, yeah.
But hey, we're adults, and we don't need school and teachers all the time. I mean, we may not use school and teachers, but do we learn all the time? Yes, we do.
We're always learning. Yeah. Okay, everyone. True Zero Emission signing off for the moment. And I keep reaching the 100 limit video maximum for short videos. Otherwise, I would just keep making them because I like sharing all my experiments with you. Each video is meant to be showing something different or new, or I'm definitely thinking of different things in each video I make, and I'm hoping to convey a sense of that to you in the videos that are made in each video. So I want to thank all of you for your support, and thank you for your interest, and thank you for just being an active learner and being open about learning about the open universe, the open super system. And special thanks to Tom Bearden and all of you that are a part of the journey of discovery. Bye, Cameron.
See you later, folks at home. Keep on learning.
And I like your shirt, by the way.
Oh, thank you. It's old school.
It says, do you want to read it?
I can't actually read it from where I am, and I'm going to get it wrong. It says, raise your hand, raise your hands in the air. Well, how does that rhyme go? Like, throw your hands in the air and shake them like you just don't care? That's what it means, but it's in colloquial, annoying English class language. So it's something like, raise thine hands into the air and flail them about as if no repercussions will come to thee. That's a good ending.
Wow, good theater work there. Okay, bye everyone. True Zero Emission signing off. Have a great day. Bye-bye.